Think you know the world's climate story? Here's a challenge. Try to explain how a scientist from 100 years ago called today's environmental crises with startling accuracy. Bet you'll be surprised by the answer. How did someone living 100 years ago foresee the environmental challenges we're currently struggling with? It's almost hard to believe, but one of the first warning voices about humanity's role in altering the planet's climate came from a Swedish scientist named Svante Arrhenius. Born in 1859, Arrhenius wasn't an environmental activist, at least not in the sense that we think of today. He was a physicist and chemist who became fascinated by the Earth's temperature and how it was controlled. But here's the twist. His groundbreaking ideas, which laid the foundation for much of what we know about climate science, were brushed off by many during his lifetime. Arrhenius was one of the first scientists to theorize the now widely recognized concept of the greenhouse effect. His calculations, published in 1896, suggested that increasing carbon dioxide in the atmosphere could raise global temperatures. Keep in mind, this wasn't a popular concern back then. The idea that human activities could significantly affect something as massive and complex as the planet's climate sounded far-fetched, even laughable, to many of his contemporaries. After all, this was the late 19th century, when industrial smoke was seen as a symbol of progress, not a threat. But Arrhenius wasn't working from guesswork. His prediction came from a meticulous process of mathematical modeling, albeit with far simpler tools and methods compared to today's technology. He began by focusing on the heat-absorbing properties of carbon dioxide and water vapor. These gases, he noted, had the unique ability to trap heat radiating from the Earth's surface and prevent it from escaping into space. Arrhenius painstakingly calculated how changes in CO2 levels might impact global temperatures. What's incredible is how close some of his estimates were to the changes we're actually observing today. He predicted that if CO2 levels doubled, global temperatures could rise by about 5 degrees Celsius. Modern climate science, armed with satellites, supercomputers, and precise measurements, has confirmed that this range isn't far off the mark. For a person working with hand-drawn graphs and slide rules, his accuracy is remarkable. So, why wasn't this taken more seriously back then? For one, Arrhenius himself didn't sound any alarms. He framed his findings in a way that seemed almost positive, suggesting that a warmer climate could bring milder winters and boost agricultural productivity in colder regions. This optimism likely dulled any sense of urgency that his data might have otherwise sparked. Plus, the scale of industrialization at the time was still modest by today's standards. Enough to increase CO2, sure, but not yet to the levels we're seeing now. Skeptics of his time argued that the planet's natural systems, like the oceans and forests, would absorb most of this excess carbon. They underestimated just how much humans would ramp up fossil fuel burning in the 20th century and beyond. What's eerie is how closely some of Arrhenius's predictions align with today's climate realities. Take the rising levels of CO2 in the atmosphere, for instance. When Arrhenius published his work, CO2 concentrations were roughly 295 parts per million. Today, they've reached over 420 parts per million, and we're seeing the consequences he described: higher average temperatures, melting polar ice, and shifts in weather patterns. He couldn't have guessed the exact details, for example, the rise in extreme hurricanes or massive wildfires, but the broad strokes of his prediction hold up under scrutiny. His work wasn't just a fluke, it was based on quantifiable logic and observation. Yet, his ideas weren't widely embraced, partly because climate change wasn't an immediate threat. Industrialization was seen as humanity's unstoppable march forward, and Arrhenius's work, while respected in academic circles, didn't make headlines. By the time scientists started seriously revisiting the greenhouse effect decades later, the world had already locked itself into a path of rapid fossil fuel dependency. What makes this even more concerning is the missed opportunity to change course before the damage became so widespread. Imagine if his prediction had sparked a global conversation about sustainable energy a century ago. How different might things look today? So, here's a question worth considering. Why did the world shrug off such an important insight? Was it pure ignorance, the comfort of believing the planet was too vast and resilient to change, or something else entirely? Whatever the answer, it's clear Svante Arrhenius' prediction was far more than a lucky guess. It was rooted in the power of numbers, logic, and observation. Elements of science that we now know are some of humanity's best tools for understanding the planet. But understanding only takes you so far. Taking action is where the real difference gets made. How could science from over 100 years ago, in a world without supercomputers or satellites, come so close to predicting the climate challenges we face today? The answer lies in the brilliance of a handful of early scientists who pieced together how the Earth's atmosphere actually works. At the core of their discovery was the greenhouse effect, a now well-known process where certain gases, like carbon dioxide, trap heat and prevent it from escaping into space. But back then, it wasn't common knowledge, and not everyone agreed on how significant this phenomenon could be on a global scale. The groundwork for this understanding goes back even further than you might think. In the early 19th century, scientists like Joseph Fourier and John Tyndall were already exploring how heat circulated in the Earth's atmosphere. Fourier first likened the Earth's atmosphere to a glass jar where sunlight entered, but heat couldn't easily escape, a concept not far from what we call the greenhouse effect today. But it was Tyndall who took the next critical step, identifying that certain gases, like water vapor and carbon dioxide, were particularly good at absorbing heat. What Tyndall didn't know, and what later scientists like Svante Arrhenius clarified, was how even tiny changes in the concentration of these gases could have an enormous impact on global temperatures. Arrhenius's breakthrough came in 1896 when he used detailed calculations to estimate how much the Earth would warm if atmospheric CO2 levels doubled. He didn't have the complex climate models we use now, just basic physics and a lot of patience. He divided the Earth into zones, calculating how heat behaved in each one. Though his work was time-consuming, the numbers he arrived at were shockingly close to what modern science predicts: a temperature increase of roughly 5 degrees Celsius for a doubling of CO2 levels. To put this into perspective, even today's climate models, powered by some of the best technology in the world, predict a similar range for a similar scenario. Arrhenius was mapping out something groundbreaking with fewer tools than we'd use to design a smartphone app today. But, like all new ideas in science, it didn't go unchallenged. Back in the early 20th century, many believed the Earth's climate was regulated by natural systems that would buffer any human influence. A common argument at the time was that the oceans, being so vast, would absorb excess carbon dioxide before it could accumulate in the atmosphere. Others pointed out gaps in Arrhenius's calculations. For example, he didn't fully account for the role of aerosols and cloud formation, which can complicate the exact relationship between CO2 and a temperature. These debates delayed the recognition of his work as something serious and urgent. The fact that a 100-year-old prediction about Earth's climate has come true should make us question how we value scientific warnings. Arrhenius, using only the tools of his time, uncovered truths that modern science continues to affirm. Today, we don't have the excuse of limited technology or incomplete understanding. We have the knowledge, we see the impacts, and we understand the stakes. So, the question is, what will we do about it? Will history repeat itself, or can we act before predictions become irreversible realities? Maybe looking to the past is the key to changing our approach to the future.